friends, welcome to video lecture on dynamics of machinery. In the today's lecture, we'll discuss about basic concepts of vibration. So, we will learn basic concepts of vibration with the help of following points: definition, importance of the study of vibration, basic elements, causes, effect, and elimination of vibration, definitions and basic terminology. So let's start. What exactly is vibration? Vibration is mechanical oscillation about a reference position. Vibration is an everyday phenomenon. Now see, vibration is mechanical oscillation about the reference position. We can discuss this with the help of simple spring mass system. So see the oscillation of this spring mass, or this one mass, about its mean position. Okay, so three different possibilities are shown here. Okay, just see, every mass vibrates about its mean position. If you consider this is the mean position, so maximum displacement towards the one side, okay, in this way, towards the another side, okay, in this way. So vibration is a result of dynamic forces in machines which have moving parts and in structures which are connected to the machine. Different part of the machine vibrate with the various frequencies and amplitudes. Vibration causes wear and fatigue. It is often responsible for the ultimate breakdown of the machine. Let us see importance of the study of vibration. How that vibration is connected with the human activities. Now see, these are the human activities where the vibration term comes into picture. Most of the human activities involve vibration in one form or other. For example, we hear because of eardrum vibrate. Okay, we see because of the light waves undergo the vibration. Breathing is associated with the vibration of lung. Walking is associated with the vibration of legs and hands. Okay, we speak because of the oscillatory motion of tongue. Then vibration makes us snore, and this is an important part in human life, that is heart. Our heartbeats are directly related with the vibration. Apart from this human activities related with the vibration, see the engineering applications of vibration. So early scholars in the field of vibration concentrated their efforts on understanding the natural phenomenon and developing the theories to describe the vibration of physical system. In recent time, many investigations have been motivated by the engineering applications such as design of machines, then foundation structure. Okay, so this is the structure of particular machine we are considered. This is the foundation given for any machine. Okay, so next up is related with the engine, then turbine. Here the Pelton wheel or Pelton turbine, okay, is shown. So what's about this one? Locomotives, control system, whirling speed of shaft. These are the applications related with the engineering, okay, where the involvement of the vibration is there. And this study is not limited to whatever the diagram shown here. Apart from this one, many engineering applications are comes into picture, where there are the rotating parts are involved in the machinery. So apart from the machinery itself, the surrounding structure also faces the vibration hazard because of this vibrating machinery. The common examples already we have seen, the locomotives, then diesel engine, okay. And sound, actually a foundation is given for any machine part, etc. Now say, what are the main causes of vibration? So main causes of the vibrations are shown as shown in the figure, okay. So first one is nothing but the unbalanced forces in the machine. Okay, these forces are produced within the machine part itself. So dry friction between the mating parts. Now see the example, dry friction between the two mating parts. So what's about the friction? Frictional is nothing but here the opposition for the motion of any part, okay. So frictional force comes in between the two surfaces, okay. Now if you look towards this example, okay, shown in front of you, this example is nothing but the, here the belt is continuously running on a pulley, okay, on which simple spring mass system, okay, is attached. So mass is directly rest on the surface of this one, belt surface. So whenever the belt surface moves in forward direction, this block or the mass, okay, moves with that particular belt. But again, because of the restoring property of this one spring, the mass comes at a backward position, okay, like this one, okay. So in this way this will move in forward direction and backward direction. But the main discussion is here, the dry friction, the lubrication is not provided between the two surfaces. That's why this moves along with this surface. Then what's about the next one? Next is nothing but the external excitations. So external excitations may be periodic. Then next one is nothing but the random or the nature of impact. So periodic, if you take the example of simple pendulum, okay, the periodic vibrations will come to the picture. Random excitations, whenever the, we take the example of earthquake, okay, so we cannot predict whatever the force comes from the bottom of earth, okay, we don't know the value for this one. So this is the case of a random excitation, okay. So next one is nothing but the nature of impact, when large amount of the force is acting on the particular system for the shorter duration of the time, this is known as impact, okay. Now next cause for the vibration is nothing but the earthquake, okay. So as we know, these are the responsible for the failure of many buildings, dams, etc. So next one is nothing but the winds. This may cause the vibration of transmission and telephone lines under the certain conditions. Next part is nothing but the effect of vibration are as follows. So effect of the vibration is nothing but the excessive stresses, then undesirable noise, then looseness of the part, and partial or complete failure of the part. This can be seen with the help of these various diagrams shown here, okay. Now excessive stresses, undesirable noise, if you just look towards this one, when the excessive stresses comes inside of the machinery parts, then what will happen, the undesirable noise, okay, comes into picture. Also the looseness of the part takes place, okay. If you just see the nut bolt, okay, that will loosen from its foundation, okay. Then that leads towards the partial or complete failure of the parts or particular system. The next one, in spite of these harmful effects, the vibration phenomenon does have some uses also. For example, in musical instrument, vibrating screen, shakers, component feeder, concrete compactor, ultrasonic cleaning baths. Okay, just see the first example we have seen here, musical instrument, then vibrating screen, okay. The next one is the shaker, okay. So next one is the component feeder, then concrete compactor, then ultrasonic bath. These are nothing but the useful vibrations, Okay. Next one is the thing, but so how we can eliminate the vibration? So up till now we have seen the what is the cause of vibration, then what is the effect of the vibration. Now the next point comes to the picture, that is nothing but the elimination or reduction of the undesirable vibrations that can be done with the help of this following methods. Okay, so first one is nothing but the removing the causes of vibrations, then putting the screen if noise is objectionable. Okay, then placing the machinery on the proper type of isolators, then shock absorbers, then dynamic vibration absorber. Just see with the help of some of the diagrams. Okay, so what's about this one? So already you've seen the name here, shock absorber. Okay, so whatever the shock, now just see the example of the four-wheeler. Whatever the shocks comes from the road, okay, because of that uneven things are available on the road. Okay, the tendency of this one vehicle moves in upward direction and downward direction. Okay, that shock waves can be absorbed with the help of this shock absorber, okay, shown here. So next one is the thing but the removing the causes of vibration. Now if you look towards this one, this okay, diagram shown here. So whatever the cause earlier we have seen, if you remove that cause, then we can just make that particular machine free from the vibration. Okay, if you look to us here, here something actually a probe is shown. Okay, or accelerometer is here. Okay, with the help of this one we can get the information from that particular machinery. Okay, and according to that we can give some treatment for this particular machine. In this way, you can just remove the cause of that particular vibration comes in that particular machine. Okay, so placing the machinery on proper type of isolators. So if you look towards this one, complete actually foundation given for this particular machine. Okay, so whatever the vibrations comes because of this rotating parts are consist in the given machinery. Okay, when we give the foundation, proper foundation for this one along with the isolators, then we can remove the vibrations. So what's about the next one, dynamic vibration absorber. Now see the this picture looks a very simple one, but the dynamic vibration absorber. Okay, so this part can be explained with the help of this one spring mass, and again this one red spring and mass system is attached. So if you consider this is nothing but the primary system. Okay, and this is nothing but the auxiliary system or secondary system. When we attach the secondary system to the primary system, so whatever the vibrations comes from the primary system, that can be absorbed by the auxiliary system, and the primary system becomes free from the vibration. If you look towards the second picture, this is known as dynamic vibration absorber. This can be clear to you in the next parts. Then say, what are the elementary parts that are involved in vibration system? Now if you look towards this one, vibration system consists of mainly three parts. First one is nothing but the spring, mass and damper. Okay, so what's about the spring, mass and damper? What's about the function of every parameter involved in that vibratory system? So here in vibrating body there is an exchange of energy from one form to another. The energy is stored by the mass in the form of this one kinetic energy. Okay, in the spring potential energy. Okay, then next one is the thing but dissipated in the damper in the form of heat energy which opposes the motion of the system. So energy enters in the system with the application of external force known as excitations. So whatever the disturbing force occurs or comes in the system, that is nothing but the excitation. Okay, so what's about this one? These are nothing but the mechanical parameters and its component. We can just club, okay, here to know the information regarding this one, vibration parameters. If you look towards this one, so what's about this one? A simple spring in front of you. When we push that spring, okay, by a distance here d, okay, so that can be indicated with the help of letter d. So what's about this one? With which velocity the displacement occurs? Okay, so v velocity is shown here. And what's about the rate of change of this velocity? That can be indicated with the help of this acceleration term. Okay, now what's about this one? What's about this force? This force is nothing but the spring force. So we know the basic definition for the stiffness. So what's about the stiffness? Stiffness here, unit for this one, Newton per meter. So what's about this one? If I divide this k term here, okay, so what's about this one? Force per unit displacement. If I take this d here, okay, d goes in denominator, okay, means here what we get here, stiffness is nothing but force per unit displacement. Now see in the next picture, so whatever the velocity comes into picture, okay, so displacement, rate of change of displacement is nothing but here velocity. So c parameter will comes into picture. That c parameter is nothing but the damping coefficient. Okay, so c multiplied by this one v is nothing but the damping force. Okay, in earlier case k multiplied by d, stiffness multiplied by displacement is nothing but the spring force. Similarly, this one v multiplied by this term, okay, c is nothing but the damping force. Okay, similarly, whatever the rate of change of velocity is nothing but the acceleration. If I multiply by this acceleration term with the mass term, what we get here? Accelerating force. Okay, so first one is nothing but the spring force, next one is nothing but the damping force, last one is nothing but the accelerating force. So in this case, whatever the conversion of energy takes place continuously from potential energy to kinetic energy and kinetic energy into potential energy. Now see the definitions and basic terminology. So definition part will start with the help of this simple harmonic motion. Before a direct discussion of that definition, just look towards this diagram. So let us consider here any particle starts its journey from this point. Okay, now look towards this one, black point. Black point start its motion from this spot, okay, reaches up to a maximum position, again in opposite direction, again reach towards the maximum position in another side, and again comes at the mean position. Okay, so whatever the displacement takes place for that particle from this point towards the this one vertical axis, we'll just say this one in terms of, if I say this is nothing but the theta. Okay, so theta here shown in terms of omega t. So what's about the basic definition for this omega? Omega is nothing but the, so what's about that omega? Omega, rate of change of angular displacement with respect to time. Okay, theta by t. Okay, so if I take that t from denominator towards the, okay, numerator, then omega t is nothing but theta. Okay, so you can get this one theta, okay, in terms of omega t. So what's about this one? This picture, okay, shown here at any instant, if I say this one, this point, so what's about this one? If I consider this is nothing but the omega t. Now focus on this small triangle. So what's about this one? This is x, capital X. Okay, so what's about this one? This is nothing but the displacement, linear displacement for that particular particle. Okay, so if we focus on this small triangle, okay, so can I write for this small x as x into sine omega t? Okay, same equation is written here. Consider the simplest equation of a vibrational motion, that is small x equals to capital X into sine omega t. So what's about this one x? So already I discussed about this x. X is nothing but displacement measured from the mean position at time t. So how you can get the velocity at time t? For that you have to differentiate this equation with respect to timing t. So x single dot. So this x single dot, now onwards we can use this one to represent the velocity. Okay. So x single dot equals to, if you differentiate this x term with respect to timing t, what do you get? Dx by dt equals to, what's about the derivative of this term? So x will remain as it is. Derivative of this sine omega t is nothing but omega into cos omega t. Okay. So give equation number next for this one. Again, acceleration at time t is nothing but the differentiation of this equation. So x double dot indicate the here acceleration term. Okay, x double dot. Unfortunately here x single dot shown, but just consider this one x double dot. Okay, so x double dot equals to d2x by dt square. So differentiate this equation with respect to timing t. Okay, so x omega will remain as it is. What's about the derivative of cos omega t? Minus sine omega t, again derivative of this one omega t will remain, so we can get the omega. So omega multiplied by this omega is nothing but the omega square. So what do we get here? X double dot equals to minus x into omega square into sine omega t. In this way you can get the relation. So if you look towards this one, capital X into sine omega t, so already this relation with us. Okay, small x equals to capital X into sine omega t. You can replace this x into sine omega t term by small x. Okay, small x, and here what's about this one? Omega square will remain as it is. So what's about the final relation we can get here? So in this way I can get the final relation for the simple harmonic motion, that is x double dot plus capital X into this one, sorry, small x into omega square, okay, equals to 0. So in this way I can get the relation for the simple harmonic motion. Okay, x double dot plus small x into omega square equals to 0. Now see the definition for simple harmonic motion. Such vibrations where the acceleration is proportional to the displacement and is directed towards the mean position indicated by the negative sign. Okay, here the that is indicated by the negative sign. Okay, negative sign with us here is called a simple harmonic motion. The plot of this equation is shown here. Okay, so this equation small x equals to x into sine omega t, this plot already shown here. Once again see this definition: vibrations where the acceleration is proportional, acceleration means here x double dot is proportional to the displacement and is directed towards the mean position, directly proportional to this x and directed towards the which one? Towards the mean position. So mean position is here. Okay, so negative sign indicates the directed towards the mean position. Already this plot is shown here. Okay, so the vibrational displacement can be considered as the end of rotating vector of length x. Okay, here is the length x at speed omega on the vertical axis, where capital X is the amplitude or maximum displacement from the mean position. Okay, here is the mean position. Okay, so displacement of the particle takes place from this point towards the maximum position, then towards, okay, this one mean position in the opposite side, then again, okay, towards the maximum position, and again at the same point. Okay, now see the another definitions. ready with the same point. Cycle. So what's about the cycle? The movement of the vibrating body from its undisturbed or the equilibrium position to its extreme position in one direction, then to the equilibrium position, then to its extreme position in the other direction, and back to equilibrium position is known as cycle of vibration. Okay, this can be seen with the help of this motion of this one. Just see the black point actually start its journey from this, okay, point, and again comes at the same point. Okay, the movement of the vibrating body from its undisturbed, so here is the undisturbed, okay, or the equilibrium position. Okay, and the motion of this particle start from its undisturbed position, hmm, and reaches up to maximum position. Okay, then to equilibrium position. This is nothing but the opposite side of that equilibrium position, then towards the another side of that, which one, the maximum position, and again back to equilibrium position. This is known as cycle. Okay, or this journey start from this point up to here. Okay, this is known as cycle. So what's about the amplitude? So amplitude is nothing but here the maximum displacement of vibrating body from its equilibrium position is called the amplitude of the vibration. Okay, this is known as amplitude of vibration. Okay, so what's about the period of oscillation? The time taken to complete one cycle of the motion is known as period of oscillation or time period. Okay, and it is denoted by this one t letter. It is equal to the time required for the vector OP. If we just consider this one vector OP, okay, so here I consider P point, then whatever the time required for this vector OP, to rotate through an angle, this one 2 phi, means the complete motion of this particle takes place from this point and again at the same point. Okay, so angular displacement here is nothing but the 2 pi. So what's about the time period? Time period is nothing but the 2 pi divided by omega. This is the definition of this one omega. Omega, if I take this one 2 pi here and timing t here, so what's about the omega? It is the rate of change of displacement with respect to timing. Okay, so what's about the frequency of oscillation? So frequency of oscillation is nothing but the number of cycles per unit time is called frequency of oscillation, or simply the frequency, and is denoted by f. So f is nothing but 1 upon t. Okay, equals to, you have to take just the reciprocal of this one, omega divided by 2 pi. Here omega is called the circular frequency to distinguish it from the linear frequency, that is that is f equals to omega divided by 2 pi. Okay, the variable omega denotes the angular velocity of the cyclic motion. F is measured in cycles per second or hertz, while is measured in radian per second. So omega is measured in radian per second. So what's about the natural frequency? If the system after an initial disturbance is left to vibrate on its own, the frequency with which it oscillates without external force is known as natural frequency. Okay, as will be seen later, a vibratory system having n degree of freedom will be in general n distinct natural frequencies of vibration. Now we will look towards this one. Okay, simple spring mass system is there. Okay, you just see the journey of a particular particle. We have just seen a circular motion of this one. We have seen with the help of simple particle. Okay, so same can be seen with the help of the spring mass system. Okay, so next important point is nothing but, now see what's about this one, interesting one. So this is nothing but the case of resonance. Now say the vibration of the system when the frequency of external force equal to the natural frequency of the system. The amplitude of the vibration at resonance becomes excessive or maximum, resulting in mechanical failure. Resonance result when the vibration of an object are matched with the similar vibration. Now say this example, okay? So this gentleman actually try to push this one, whatever the platform provided for this one. This four different actually a bob connected with the help of string, okay, shown here. I'll just say the every object here is nothing but the simple pendulum in vertical direction. Okay, so this gentleman actually tried to pull the platform of this one. So whatever the frequency of this one comes and whatever the natural frequency of this one when matches, then if you look towards the last simple pendulum, this will start vibrate with the maximum amplitude. Okay, this is the case of resonance. I hope in the today's lecture the points related with the basic concepts of vibration such as definition, then importance of the study of vibration, basic elements, then causes, effect and elimination of vibration, definition and basic terminology are clear to you. Thank you.